So my name is Rohit Agarwalla. I'm going to cover a little bit in detail exactly how Contiv differentiates compared to other solutions that exist. And then we will discuss a couple of use cases from a container networking perspective and how Contiv is enabling that using the policy model. And then we'll specifically look at the ACI integration, and our demo will be around in a Kubernetes environment, how you can spin up multiple pods and achieve isolation, as well as use the policy model in Contiv to basically connect these different pods in a way that the developer actually requires. So let's look at the use cases first, and then talk about how this is being done under the hood, right? So the idea here is that there should be an ability to provide microservices security in a scalable way. And what I mean by that is captured in two pictures. The first one, I should be able to deploy these microservices in their own networks. So each and every microservice or container or a pod, if you will, is attached to its own network, having its own segment, whether that be a VLAN, VXLAN, an L3 VRF, whatever the backend implementation is. In addition to that, when these pods are connected to their network, I should be able to control what part of the application is actually exposed to the other components. This could be other VMs within the data center, or it could be other pods that are attached to the same network. So that's our first use case, where you see the microservices that are within that same network, which ones can talk to each other and what cannot within that same network. And we'll see that in the demo as well. The second part is, now that I have created these and attached to the network, I want to group them in a way so that only certain groups can talk to each other. And then also use some of the advanced capabilities in the ACI framework itself, so that I can connect my VMs that are not part of my Kubernetes or my Docker environment to VMs that are in VMware or in OpenStack, or even bare metal servers that are connected to my ACI fabric. That's the deployment that we see becoming more and more popular and more demanding, that as the world is changing to an environment where you have VMs, containers, and bare metal, all three of them as first-class citizens in your data center, you need to have a networking fabric that can connect these three things in the first place, and second, in a consistent way, apply policies across these things. So we'll see actually how Contiv's policy model is enabling us to achieve both of these use cases. So the policy model is captured here. So what we have is a tenant that basically creates a network. And this is where your pods or your containers would come up. And once you have that network created, then you define your endpoint groups. Now you would probably start thinking this is very similar to the ACI model, because you've heard that previously in ACI. So guess what? It is actually borrowed the same model into Contiv for containers, that we have the concept of endpoint groups and policy and rules within for containers as well. So that's where the endpoint group is, that it is attached to a network to provide that isolation that I was just talking about. So within the endpoint groups, I have a bunch of policies that I can define for that tenant. And these could be policies that enable both ingress as well as egress traffic, or on different ports that I want to enable for my container traffic. And then within that policy construct, I can define the set of rules that need to be part of that. And finally, I have the app itself that is going to be spun up on the network. So when I create that app, and you will see in that demo, I'm spinning up a DB app or an application, or an Alpine container, that app basically inherits all the policies through the endpoint group, which is attached to that network. So this enables Contiv, when you're using, along with ACI, the group-based stickiness that you have within the ACI framework, and the two use cases of creating separate segments for your container network, as well as enabling granular control of what gets exposed to the other pods within that same network and to the rest of the infrastructure, can all be managed by this particular model. So from an ACI integration point of view, we have our container management systems on the left that are Docker Kubernetes. You can use those, and we have the ACI gateway container as part of Contiv that basically communicates, or the APIC plugin in this case, that communicates with APIC to push down the policies within the ACI fabric. So when containers or pods come up on the container host, what's happening is that the Contiv plugin that's sitting on the host is actually programming the Open vSwitch, which is our forwarding switch that we use for both the connectivity as well as for the policy implementation. And today,
So in Docker case, you would write a network provider plugin for Docker, so that instead of using the standard stuff that Docker does, they would call you and you would do your stuff instead.
That's exactly. So Docker has a container network model, which is the CNM model. So we have a CNM driver for Contiv in Docker. Kubernetes has a CNI model, which is the container network interface model. So we have a Contiv CNI driver for that implementation as well. And that's exactly what you see is the hooks that in both of those models we call using our plugin basically in those models. The Contiv master calls the Contiv APIC plugin underneath that programs the entire fabric with the connectivity for the containers as well as the policy that is associated with the containers network itself.
So in the APIC plugin, you would effectively get the information from Docker that this host, well, this container on this host and that container on that host need to talk to each other. And then you would translate that into endpoint groups in APIC and configure dynamically the endpoint group endpoint so that they get connectivity that they need.
That would have been absolutely the best scenario if Docker had a policy model in their orchestration system, but it does not exist. And guess what? That's where Contiv brings in the value add, that Contiv runs alongside these container orchestration engines and provides you with the CLI interface as well as the GUI to actually create these policies. And it then communicates with the container orchestration engine itself. So when a pod is coming up or a container is coming up, we basically talk back into the Contiv master to get all of that information and program it appropriately into the host forwarding pipeline itself.
So you have to define the policies in advance, and then when you start the workload,
then you reference those policies, and you'll see that in my Kubernetes environment, for example, when I'm creating my pod spec or my replication controller, I'm specifying labels that this is for tenant compute. It is supposed to go on compute network, and it is supposed to have a policy of compute network app policy. Using those labels, Kubernetes is going to bring up and send all of that information to our CNI Contiv driver, which understands what to do with that pod connectivity because it understands all of those labels that you have just specified along with your pod spec.
So you're getting metadata from the orchestration system.
Correct.
And then you do lookup into your policies based on that metadata, and you find out what you need to do.
Exactly. Bingo. You hit it right on the head. Okay, so I think in this summary slide, we provide both with Docker and Kubernetes connectivity using the ACI fabric. Of course, that means all the L2 connectivity as well as the L3 connectivity for your containers and pods will now be taken care in the ACI fabric itself. And then that these ACI policies now can be extended to bare metal as well as VMs. So from an ACI fabric implementation point of view, whether it's a VM or a container, it's an APG at the end of the day that gets exposed into the ACI fabric, right? It's an endpoint that the ACI understands, and you define how these endpoints can talk to each other through contracts. So that enables us, the APIC admin or the data center administrator that is controlling APIC, to define how all of these communications can take place. We'll actually touch upon a unique case of how Contiv can actually reference a policy that exists within ACI and consume that into a container environment. So in this case, the policy is already defined, but the container workload is using that policy that is already defined.
In the traditional VM world, you have the problem of not being able to control what happens within the hypervisor unless you're running AVS on the hypervisor.
Correct.
And here it looks like you are using OVS as your own application virtual switch.
Correct, and that's so. This can be a container or a pod can be running within the VM itself. In which case, the OVS is within that VM because the pods are getting connectivity through the OVS that's sitting within that VM. So for the VM connectivity, it's on the host, which is AVS, right? Within the VM for the containers, it's OVS that's providing the connectivity. And of course, you can deploy containers or bare metal on the bare metal, containers or pods on bare metal directly, in which case you just have OVS providing the connectivity for the pods and the containers. Okay, so this is our demo topology. Quickly walk you through this. So we have, I have VMs running on my ESX cluster. And what I'm doing is I'm spinning up pods using Kubernetes cluster. And I've got app 1 and app 2 as 2 pods from the app endpoint group. And I've got a DB pod from the DB group. And then I've got an ESX, I've got a legacy VM that's running on here, which is basically already exposing an external contract into my ACI fabric. What I mean by that is that the connectivity for that VM has been already defined by my administrator, that I'm going to only enable the ICMP traffic to come for that VM. What I'm going to show in this demo is that when I spin up these pods, app 1 will be able to talk to app 2 because they are part of the same endpoint group, which is my app. But app 1 will not be able to talk to DB because these are part of 2 different endpoint groups. And then third, we'll also see that app 1 is able to talk to the legacy VM because I'm going to be referencing in the app group this external contract. So I'm telling that app will be able to consume the external contract that is being exposed by this VM. And that's all through the ACI magic underneath. But my DB pod will actually not be able to talk to this guy because my external contract is not referencing the external contract is not being referenced by my DB pod. So we'll see all of this in the demo, and it'll become a little bit more clearer. So this is my VM1. This is my master. So if I do kubectl get, wow, the VPN is really nice. Oh, no resources found. Let's do nodes. So of course, there are no pods right now running in my system. We're going to run through a script that will spin these up. So I've got 3 nodes. I've got my VM1, which is my Kubernetes master. And I've got VM2 and VM3 as my worker nodes. And I've got a script here that is basically going to run a bunch of commands. And what I'm going to do is just run them, and as the commands get executed, explain what's actually happening under the hood. Before that, if I go back here into my Epic UI, I've got a compute tenant that has been created, and basically we'll be referencing this tenant for most of our demo purposes. So let's get into the compute tenant here and see what exists actually at the moment and what will change when I'm running my script. So we'll just give this a second to load up. So here we can see in the application profile, I've got the external VM profile created. And within the EPG, I have the EPG for the VM that I spun up. So this is the external contract that I was referencing in my demo slide from a topology perspective that, come on. You'll see basically the mapping that exists from a implementation point of view. If I go into my operation, I can see this is the IP address that has been assigned to this VM, and this is what we'll be using when we actually try to ping this guy. If I go into my external VM profile, I'll be able to see the contract that is being exposed here. And you can see here that I'm only exposing the ping for that external contract. And if I go into my Contiv UI, so this is the new UI that Kiran was talking about that we have come up with. And here you can see I don't have much networks or application group or application profile or any network policies created. So as we go through this demo, you'll see these things start to populate because, of course, using the CLI through script is much faster than doing things through the UI. So let's go ahead and start this up. And this is just telling me about the version of Docker that I'm running. So here, the first thing that I'm doing is that I'm setting my global networking mode here to be the ACI mode, and I'm using the following VLANs for that purpose. So this is the prerequisite that I need to do, because when I am creating my pods, they will be using a particular VLAN out of this range. And what will happen is that the ACI fabric will then encapsulate and forward the traffic appropriately. Let's continue here. This is, by the way, the netctl is the Contiv CLI command that you're using in addition to the Kubernetes to create and set some of these things. So now I did, let me actually, that's a wrong script, right? Should I get out of this and come back? Let's, I missed a Kate's in between. That's it. So this is a better one. This is with Kate's, of course. All right, so here we see Kubernetes, the nodes that I just showed. So here are the 3 nodes that are running, doing the same command of setting the forwarding mode to ACI with the VLAN range that I just talked about. Here we created the tenant compute. So this is the compute tenant that I was referencing. And when we do a netcuddle tenant ls, I can see the different tenants that exist within the Contiv database. Let's proceed here. So here I'm running basically the netcuddle command to reference the external contract that I was just talking about that was created within the ACI for the VM itself. So I've created a VMM HTTP provide as well as a VMM HTTP consume. So in terms of the ACI implementation, a VM that is providing a contract, the pods will consume that. And since we are doing a ping test, we also want to provide this back into the ACI fabric so that the request and the response goes through fine. So this is for the connectivity to the VM from the pods. Now we will go ahead and create a network. So this is the different workflow that comes along with Contiv, that you're creating a network for that container orchestration system, specifically using the Contiv CLI. So here I'm specifying the encapsulation type to be VLAN. I'm using the tenant compute. I'm specifying the subnet. And I'm also specifying the gateway for this. So what's going to happen now, once all of these gets configured into the ACI fabric, is my default gateway is going to get created within the ACI fabric itself for that particular network. So that brings in the advantages that all the L3 forwarding now for that container traffic is going to be taken care of by the ACI implementation. Now here
just a quick question on that one. You have the encapsulation can be selected. What other encapsulation do you support?
Very good question. So like we had mentioned, Contiv supports different backend implementations. So you can say VXLAN as your encap with Contiv. You can say L3 forwarding as your encap, which will be using BGP. So we actually support routing and bridge mode as our 2 forwarding modes. So in case of bridge mode, you have either VLAN or VXLAN. And in case of routing forwarding mode, you have L3 BGP as your implementation under the hood. And of course, with ACI, we are still tagging the packets with the VLAN on the host. But the encapsulation for the VXLAN is taken care of by the ACI fabric.
Okay, and the last question, is this also possible for IPv6?
Great question. Today, the community itself is not ready with IPv6. I mean, go into the Kubernetes community, and they're still evolving as to what is the right model to provide IPv6 from a control plane perspective. And then from a data plane perspective, that comes the second chapter. So in Contiv today, we are still awaiting some of those developments to take place, but we are actively engaging in the community. For example, we are leading, for example, the multi-network support in Kubernetes for our pods and how we can enable that design spec. So we are actively engaged in the community, but IPv6 is still a little bit away from an implementation point of view, at least.
So let's say it's on your to-do list, yeah?
Absolutely, it is on our to-do list.
Okay, great.
Okay. So here you can see that when I did a network netls of my tenant compute, I have this created, and the podnet is my network name. So when I'm creating these policies, this is the podnet is what I'm going to be referencing going forward. So let's go ahead and say yes and continue here. So now I've created my endpoint group. So this is where I'm starting to now group things specifically according to the policies. So what I've done using my Contiv CLI, I've created a group, and I'm referencing the external contracts that I just created here for that tenant, right? And this is against the podnet network that I've created for my container network. And this is specifically for the app pods. So when I am spinning up the app pods, we'll be able to talk to the VM that's outside because I'm referencing the external contracts for the endpoint group that is being created here. Similarly, I'm creating an endpoint group for my DB. This is also within my podnet, but I'm not referencing the external contract here, so I will not be able to ping from my DB pod into my external VM. Let's go ahead and press yes here. So this is the last step, after which we actually send a request to the Contiv master using our plugin within the Kubernetes framework to actually program everything that we have just created into the ACI fabric using APIC. So if I go back into my APIC here first, so we can see a compute profile has been created. So this does not exist before. And within my compute profile, I can see I've got a bunch of new things now. First and foremost, I've got the EPGs that I was referencing from an app and DB perspective. I've also got the external contract that is referencing by the VM as well as by the app. So this shows that app to VM should actually work, but from DB to VM, it will not work, and as well as from app to DB, it will not work. So this is kind of a summary of all the connections that has taken place as I've just created the endpoint groups and the app profile against the container network that I just created. If I go into my admin console of my Contiv UI, I can see now within my application groups, these groups start to show up. Within my application profile, if I click on this, I can see, I can drill into that what are the different endpoint groups that are part of my application profile. Within my network policies, I can go into my external contracts and see these two policies also defined here. And these are the external contracts that were referenced in my endpoint group definition. Settings is what an administrator defines from an overall network perspective. If I go into network defaults, I can see all of the things that I had created using my Netctl CLI. All of these things are now referenced here, that it is an ACI type of infrastructure backend. This is the VLAN range that I'm using, forwarding mode being bridge because I specified the incap type as VLAN. So again, you can see the power that we are bringing, that things that are being driven through the script, our UI is getting simultaneously updated. You can very easily drive all of these things through the UI as well. Let's go back into our terminal window here and press yes to start to see that the app profile has been created and go through the next steps of the demo. So our next steps here are interesting because here is where the rubber meets the road. Now we are basically spinning up these pods within a Kubernetes environment. And going back to Ivan's question that how are we actually referencing this. So here is an example of my app1 YAML file or my pod spec. And I'm basically providing the labels, which is my metadata as part of my pod definition itself. So here you can see I've specified my tenant compute. I specified the podnet network, which I had created using Contiv, and I'm specifying that this app1 pod needs to be part of the app endpoint group. So there is specific creation and stickiness in terms of which network this pod needs to be attached with, and within that network, what grouping does that application needs to be part of. I've done that for my app1 as well, and I've done that for my app2 and for my DB as well. As you can see, I've got these 3 pods now up and running, and they have the following IP addresses assigned to them. Let's go ahead and press yes, and we are now going to do a bunch of ping tests to make sure that everything that we just talked about is implemented within the ACI fabric. So if I quickly go back and just copy my command here, so let's get into the app1 pod itself. So now I'm within the app1 pod. If I do an IPA, I see the IP addresses that have been assigned here, and I can see that it has a .1 IP address that matches this guy's IP address. So our first test is going to be that I'm going to try and ping app2, which is the following IP address. So this should hopefully work. So we can see this is pinging. Now I'm going to try and ping .3, which is my DB pod. So as you can see, app and DB were in completely 2 different endpoint groups, so I should not be able to ping this. So when I do this, the ping doesn't go through, right? So so this is kind of a summary that within the same network, I'm able to create and control through Contiv my endpoint group connections for my app and DB, which are part of the entire application, but control it from a policy level, what gets to communicate with each other. Now, our second part is that we are going to try and ping the external VM. So we had noted that the VM IP address was 101.101.101. So from my app, I was referencing the external contract for my external VM. So this thing should work, and naturally this is working. But let me exit out of this and go to my DB pod here. Wrong name. And if I do an IPA here, I can see this has the IP address of .3. And if I try to ping here our 101, this should not actually go through because I have not enabled that external contract for my DB pod. So this, in summary, tells you that how, in addition to just controlling through policies, connectivity between pods that are within the container orchestration engine, I'm also able to manage through my ACI fabric connectivity through other components within my data center, in this case, a VMware VM, and how that talks to my application components that are running as containers within my container orchestration engine. I think that was kind of all the use cases I had. Well, the final use case here is that now I can, within the pod itself, or within the network itself, create a policy that says, hey, now I really want my app and DB to be able to talk to each other, right? So I want to modify that policy also. So that capability exists as well. So what I did here now, that within my podnet group, I updated by saying that ICMP should be allowed from my app to DB. So if I know, try to go back into my app one here and try to ping my DB, I should be able to ping. And there you go. We were not able to ping DB previously, but now we modified the policy to actually enable the ping to go through, and this is happening. So if I actually look at my ACI picture now, this will actually show you that, hey, another contract has come up. So this kind of summarizes that we are able to, even at a microservices level, control that which components or which endpoint groups can talk to each other. I think that was it. My script is now going to clean up everything else. I'm happy to take any more questions. Then I would have to flip back into my demo slides or my presentation here. For more information, we got our GitHub page that has the installed releases. So our beta code is already out. We are taking POCs. We are doing POCs. There's a customer that's in production with Contiv at the moment, SAP. And they are here at Cisco Live. And they're going to be talking about how they're implementing Contiv with ACI within their production deployments. We got our documentation up on Contiv GitHub IO page. We have a nice community going where you can also participate and join in all of our conversations. And we have an active blogging going on our Cisco blog site where we have captured all the exciting new features that are coming along with Contiv 1.0 release. Here is a summary of all the Cisco Live sessions that are going to be taking place. If you're interested in watching some of these, they would be recorded. But hopefully this demo, as well as the idea of what Contiv brings in from a networking perspective, as well as from a policy perspective, chimes well and makes it the most powerful open source container networking implementation that exists today.